growing possibility that we may soon find signs of life on some moons around the planets in our solar system, such as Miranda around Uranus, Europa around Jupiter, and Enceladus around Saturn, and even in other solar systems, is bringing back the focus on an ancient theory. The theory known as Panspermia, which was given pioneering scientific framework by the eminent British astronomer Sir Fred Hoyle, who also formulated the theory of stellar nucleosynthesis along with Dr. Nalin Chandra Wickramsinghe in the 1970s, has come under renewed focus. Panspermia essentially holds that life on Earth and elsewhere was created using cosmic building blocks carried across the universe by comets and other bodies. Now that NASA has flagged the possibility that even Miranda around Uranus could have subsurface oceans and hence an environment friendly to life, the 85-year-old British astrophysicist, astrobiologist, and mathematician says his panspermia theory explains the phenomenon. Dr. Wikramasinghe spoke to Mayank Reports.
Welcome to Mayank Reports, Professor Wikramasinghe. It's a great pleasure to have you.
Thank you very much for having me again. Lots of things have happened since we last talked, so it's nice to catch up on the latest news.
Indeed.
Which is
I
really...
wanted to start, Professor, with something what you tweeted the other day, and I'm going to quote you.
Yeah.
The existence of microbial life in the subsurface oceans of the moons of Uranus, newly declared habitable, is a consequence of the Hoyle-Wikramasinghe model of panspermia. Please explain.
Well, I think the context it goes back a long time. Ever since Copernicus removed the Earth from being at the center of our world, of our solar system, half a millennium ago, and our continuing modern exploration of the universe, of space, through telescopes, space telescopes, and so on, the idea that life is confined to the Earth has, I believe, become ever more ridiculous and ludicrous. So this is the context against which the new data from all the old satellites being revised and reevaluated. This is the context against which it should be examined. I mean, just as a backdrop, we know that the solar system is made up of just an ordinary star. The sun is a very ordinary star at the center of our system, and there are 8 planets and some 146 moons, bunch of asteroids, and over 100 billion comets surrounding the entire solar system. And I think there's little doubt now that every place that is habitable must be inhabited with some kind of life form, primitive life form. So could life then, with this huge context of possible habitats, even in our own solar system, could it be thought to be confined to our little planet, our little Earth? And I think that is almost ridiculous in my view. The theory, a modern theory of panspermia that we've developed over some 4 decades now, myself, the late Sir Fred Hoyle, and a whole lot of colleagues, collaborators, students, states that life could not have started from simple molecules here on our Earth. The odds against that process are, we have demonstrated quite convincingly, the odds are just super astronomical against this process happening. So life, in our view, then, is a truly cosmic phenomenon. And it is distributed right across the universe, throughout the galaxy, throughout every habitable place in the universe, we reckon must have the legacy of cosmic life within it. So that's the backdrop against which this new observation or new interpretation of an old observation should be looked at. The moons of Uranus, of course, were examined nearly 40 years ago with one of the Voyager spacecraft that really whizzed past it and took huge numbers of pictures, photographs, made observations of these moons, and also observations of the planet Uranus. And at the time, 40 years ago, when this happened, when this experiment was done, the sun had a very, very active phase. It was throwing out huge amounts of cosmic rays and plasma and stuff like that. And the environment of Uranus appeared to the investigators at the time so inhospitable
Right.
that reckon that life could not be there. So that was the conclusion 40 years ago. But now what they've done is to re-examine this old data, because we know a lot more about the sun. We know a lot more about the interaction between the sun and planets like Uranus. And what they've claimed is that the solar activity, intense solar activity, sort of really skewed up the picture. And now they reckon that the moons of Jupiter, moons of Uranus, are almost certainly habitable. They have habitable zones. They probably have oceans, some of them underneath thick crusts of ice. So the conditions are right for life to possibly exist. And as I said earlier, it is our consequence of our theory that any habitable niche in the solar system and further in the universe has to be colonized by cosmic bacteria. The cosmic bacteria are everywhere, and so you couldn't escape the cosmic microorganisms from taking root wherever the conditions are suitable. So that's the story.
Yeah, but is it your case that without the cosmic bacteria, it's next to impossible for life to generate on any celestial body on its own, or that's not what you say?
Yeah, no, that's exactly what we're saying. I mean, we re-examine the ancient idea, the Aristotelian idea that life emerges spontaneously from non-living matter whenever conditions are suitable. That's the Aristotelian thesis, and that has been adopted by modern science for the last 100 years or so. So the conventional story is of a primordial soup on the Earth that developed some 4.5 billion years ago, in which chemistry alone was responsible for the startup of life. Now, over the huge period of time that we've been examining, that scientists have been examining this proposition, not a single experiment has been done that substantiates this claim. In fact, the origin of life experiments have been done in dozens of laboratories across the world, and there's not a shred of evidence to say that this process is a viable process. In fact, that is myself and my colleagues, have argued that such a process happening on the Earth is absolutely improbable, because of the probability hurdles that have to be overcome. And I think there's some very famous quotes from Fred and myself in which there's a statement that the startup of life from non-life in a primordial soup is less likely than a tornado blowing through a junkyard, putting a Boeing 747 together. So, I mean, these are sort of just examples of the statements that have been made in relation to the claim that life just starts up whenever the conditions become favorable chemically. That's not true. The information of life has to be there. I think the seeds of life have to be there, and so that takes a different turn in this whole story, because it means that life is probably always present in the universe. It's an ever-present entity.
In that case, Dr. Wikramasinghe, is it not possible that it could be a combination of, say, some kind of primordial conditions on a planet like Earth and what comes from outside in terms of cosmic bacteria, the two combining, and then life generating? Or you think it's entirely cosmic bacteria that leads to life?
Well, I think the cosmic bacteria, the information for life is needed to be injected from the wider universe. The situation that would develop inorganically or non-biologically in any sort of chemical soup, uh, that's practically zero. There's no information that tells you anything about the emergence of life. So we need conditions on a planet, niches, if you like to call them, on a planet where bacteria and viruses, and bacteria particularly, can take root and grow and evolve. And so that's the requirement. I think if there's no if the niches don't exist, if the habitable niches don't exist, then life in the universe will not exist. Okay, I think the picture that we developed over the past 40 years, the sort of new theory of panspermia, and I should tell you that panspermia is not a new theory, or not a theory that we invented de novo. It's a very ancient theory. It's in fact older than this primordial soup theory, which starts with Aristotle. The panspermia, in fact, starts about a couple of centuries before with a man called Anaxagoras, a pre-Socratic Greek philosopher in the West, in the Western context, even I think in India, the ideas of life being everywhere and essentially panspermia has been really very deep rooted. So it's not a new theory. What we essentially did from the 1970s onwards was primarily to look at new data from astronomy, from biology that was emerging very fast at that time, and to reevaluate all the information in relation to theories of how life might have originated. And it became amply clear in the late 1970s that the organic molecules that are absolutely important for life, relevant for life, is just everywhere in the universe. And it's sort of strewn around in the Milky Way. It's found in distant galaxies and so on. So that was the starting point in the 1970s. And in the early 1980s, we had a really crucial experiment done in the laboratory by one of my students who looked at a bacterium under space simulated conditions. Okay, he desiccated, he dried out the bacterium, took what is called an infrared spectrum of the bacterium, and then Fred Hoyle and I posed the question: can this spectrum that we predict be discovered in the wider universe? And it was really very fortunate for us that I had a brother who was also an astronomer and a mathematician who was in Australia. He was a professor at the ANU. And so he took on this quest for testing our theory. And one of the biggest telescopes then that was available was the Anglo-Australian telescope. And he used the Anglo-Australian telescope to look at the way a very, very distant star in the galaxy was obscured by cosmic dust. And what he found was that the pattern of obscuration, or the spectrum, absorption spectrum, was identical to that of a bacterium.
I
This
see.
was uncanny.
Yeah.
The data was sort of faxed over to me and to Fred Hoyle, and we just completely. I don't know what we thought, but we were really absolutely impressed by what was thrown at us, and there was no question thereafter that this is a clear proof that what our prediction of a spectrum of bacterium in space, and this was fulfilled. And it's a story that has continued over the years following the 1980s, and there's no change now that everything that is happening in astronomy is fully consistent with the presence of life, microbial life, right across the galaxy, right across the universe. So that's been our point of view, and I think no piece of evidence, no observation from astronomy or experiment in biology has changed that. And to this day, I think it remains the most viable explanation of how life came to be.
But then it begs the question, Professor, then why is it that despite its antiquity and despite the evidence that you just mentioned, panspermia still is regarded by many as a fringe theory, or you think that's changing now?
Well, it is not regarded as a French theory. French theory means that it's like theories of ghosts and so on. No, I think it was regarded as being, it was certainly unpopular. It was an unpopular theory. And the reason, I think, is that the theory of spontaneous generation, the rival theory, had become so deeply established, entrenched in the scientific community. Huge sums of money were spent and was continued to be spent on aspects of that theory. So it was a human problem and a cultural problem, because there was a cultural obstacle to even thinking that there could be a theory that was at such enormous variance from the conventional point of view. I think it's culture and tradition that really prevented an immediate acceptance of panspermia, but I believe that is changing. I think the observations that are coming telling our story is more likely, our point of view is more likely, and that's going to stick in the long term. I think facts eventually prevail.
Given the size, scale, and complexity of the universe, wouldn't panspermia, necessarily be unfathomably diverse and often even contradictory in terms of the life form that it generates?
What panspermia says is that the components of life, the really the complex genetic components of life, are determined cosmically. I mean, they're not determined on a planet. They're not determined by local chemistry. That they're a cosmic input that has been maybe always there, maybe as old as the universe itself. So that's the context against which panspermia should be looked at. So the components of life, if they can get together in different ways, you get different structures of life, different forms of life, but it's always at the level of the basic complex chemical building blocks of life. They are always the same.
I see. If life is indeed discovered in some form on Miranda around Uranus, and say for Europa around Jupiter, or even Enceladus around Saturn, do you think panspermia will gain traction as a theory?
Well, I think the immediate response would be that spontaneous generation has taken place in these places, these other locations, and discover the same solution. So I think the probability argument has to be brought to the fore, and people should realize that to have the same miracle happening once is twice is bad enough. If it happens thrice, 4 times, 5 times, and so on. So I think it's beginning to stretch the human imagination beyond the limit. So I think this is the route it's going to take. Recently, I think about 3 or 4 months ago, wasn't it? There was a exoplanet. Now, exoplanets are planets outside of our solar system. They have been looked for from around 2009 with the great orbiting Kepler telescope. Some 200 million of these have been detected and catalogued of exoplanets, that is, planetary systems outside of our own planetary system. And on one of these exoplanets that is supposed to be at 100 or between 100 and 200 light years away, recently there's been a discovery of a molecule that is only produced by life, right? Methyl disulfide or something like that. And so the big claim was that life may have been detected on this distant exoplanet. There's no mention of possibility of panspermia, but they would then say, as a instant reaction, is that spontaneous generation has happened here, and miraculously produced the same result. So,
Right.
so that's the hurdle we are facing now. I think it's going to be the case that within a decade or so, we would have, as you said, discovered the presence of life on various bodies in our solar system, moons of planets in
Right.
our solar system. We would also have discovered evidence of life on more exoplanets, right? I think that's also inevitable. And then the question is, how do you wrap it all together and decide what's happened? You either have to say that unknown, essentially miraculous process of spontaneous generation is repeated everywhere, or that the same basic components of life at a very complex level, bacteria and so on, are being just put together in different places. Wherever a habitable niche arises in the universe, I think we would find the presence of life. So that would be my.
I see. Yeah. Given your expertise in astrobiology, do you think panspermia works extragalactic? I mean, you have talked about at the universal scale, but say for the sake of argument, could the Milky Way, for instance, may have been seeded to some extent by material from the Andromeda galaxy?
I think the whole universe is just chock-a-block with the the components of life at the level of panspermia. I don't think panspermia can be confined to the solar system, could be confined to the galaxy, to our Milky Way system. It has to be across the whole universe. I think life has to be as old as the universe itself. And the information for life is probably um, already there. If there was ever a beginning of the universe, then that beginning of the universe had all the information for life somehow uh, imprinted within the structures that arose at the very earliest times. But I mean, that also, the origin of the universe is under serious threat at the
Right.
moment.
I
With
mean, you are a steady stater yourself, so
Well, I'm in sympathy with this, with Nalika,
okay.
Hoyle, Nalika, and
Right.
not Penzias, Penrose ideas
Penrose
of
is talking about the cyclical
cyclical
version of
universe.
that,
Yeah,
eon after eon after eon. In fact,
yeah.
he's on record saying that in a sense, I mean, these are his words. In a sense, it's like Hindu philosophy. He has used that term.
Oh, yeah, absolutely. I mean, there's the difference between Hindu philosophy and that kind of oscillating, undulating universe, infinite universe, is there's no difference. I think in terms of philosophy, it's exactly the same. And
Right.
now I think again the great James Webb Telescope is finding galaxies that are probably stretching the imagination to say that it's within a Big Bang timescale. Big Bang
Right.
is supposed to have been at about 13.7 billion years ago, and they're finding galaxies that are possibly
Much
older than.
older than that. Right. Right. No, but in that case, tell me now that you have new information at your command, Professor. Do you think you might rework or even upgrade panspermia as a theory?
Yeah, well, I think I'm constantly reviewing the ideas of panspermia in relation to the changing scene in terms of astronomical facts. I think that is always an important thing to do. If you have a hypothesis, you begin to wonder whether the new information that is coming in different directions either fit this hypothesis or does the hypothesis need tweaking. So far, the hypothesis that we've had from 1980s onwards, the basic structures of panspermia, have not required any change. So I think this may be arrogance to say this. I think we were dead right from the late 1970s onwards. I think there was no question that all of the structures that we see on the Earth in terms of biology the components for those, the building blocks for those components, maybe the bacterial genetic heritage that is involved, is everywhere in the galaxy, in the solar system, and beyond in the galaxy. So that's, I think, the way that things are going to be. The opposition, as I said, is intensely cultural, or I believe it is just a cultural obstacle. It is the case that if you have worked on some idea for a long time, invested a lot of money, and you don't want to immediately yield to even to powerful new data that says that you're wrong, you try to sort of hang on to the old theory for as long as possible, and that's what is happening now. A lot of big money has been involved. Whenever big money is involved, then there's a reluctance to change our course, intellectual course of thinking in a different way. But it's been our belief, my belief, and the belief of my colleagues that the facts should really direct us in the right direction, in the direction that we should be pursuing. We shouldn't yield to sociological pressures or, or sort of social pressures generally.
I'm curious, Dr. Wikramasinghe, about the cosmic seeding that takes place. It is necessarily random, right? The material that fell on Earth, for instance, would have fallen on Venus or Mercury or Moon or Mars or everywhere, right?
Yeah, everywhere, certainly. There's no question that they would have fallen on those places as well. And if they had environments that permitted them to be taken up and nurtured, they would have evolved in pretty much the same way. I mean, I think Mars is a case in question. There are still big arguments as to whether there was past life on Mars that could have been very advanced, and I haven't really studied that as carefully as I should have, but at least primitive life was proved beyond doubt to exist on Mars in the 1970s with the Viking missions, right? My friend Gil Levin, who died not so long ago, made this discovery with Patricia Stratt, his collaborator. He put up equipment on Mars. He poured nutrient, radioactive labeled nutrient onto the soil, onto subsurface soil of Mars, and found that this nutrient was taken up. And then he concluded immediately that there was life on Mars, right? But the political implications of that were really profound. This announcement was made immediately by the president of the US at that time, but the authorities at NASA thought better and said, no, hang on, we have to make sure that there are no processes other than life that would reproduce the same results. So it was a sort of pullback from a conclusion that was really quite a natural conclusion to draw from the Viking experiment, and Gil Levin and his collaborators, through to their dying day, believe that there was a sort of conspiracy against acceptance of this fact that Mars is actually a living planet. I think there will be life everywhere. If you go to, even if you dig under the ices of the south pole of the moon. I mean, the moon has been visited by an Indian spacecraft not so long ago, the first spacecraft that landed on the south pole of the frozen south pole of the moon. If they dug deep into that ice, drilled into the ice, I bet they would find microbial life. I mean, it's almost impossible.
What if life elsewhere, not just within the Milky Way galaxy, but beyond, is just microbial and hasn't evolved that? What do we do then?
Now we cannot do anything. I think
I'm curious then, are we disappointed that we are probably the best that there's been?
no, I think it's exceedingly unlikely, isn't it? If the same components, right? Just imagine a mechanoset with all these little bits and pieces, the old-fashioned mechanoset.
Right.
You throw those pieces, and you have add to it some intelligence and some desire to make things, though that process of making stuff and assembly would happen everywhere. Well, why should it happen only on the Earth? If the components are there, if the components of life have an intrinsic, which I believe that they have, an intrinsic property to self-assemble and to basically to evolve into different life forms, we've seen that happen on the Earth, isn't it? From very simple life 3.5 billion years ago, we've got more and more complex life forms and organisms. So it's from the same components that all of these structures, including humans, eventually arose. So the same process of assembly, of sort of essentially stringing together the bits and pieces in different ways, must take place wherever the conditions are appropriate. You must have the right conditions, of course. It's no good dumping this material into a very hot fire. They'll just burn up. So it has to be in warm, watery oceans, and there are many places in our solar system that we think there may be warm, watery oceans. For example, the moon of Jupiter, Europa, there's been lots of speculation as to whether there could be life underneath the frozen crust of Europa.
Right. So what I'm getting from this conversation and even earlier ones that we had, that the universe is inherently life supporting.
I think so. I think I would say that on the basis of all the evidence and the investigations we've done or we've been doing over the last nearly half a century, I think that has to be the conclusion, that the universe is essentially not only life-friendly, but maybe designed in a way to foster life.
It's an interesting choice of words. Design, you say. Physicists might flare up and say, you're introducing a designer to this now.
Designer is not. I mean, you could have designs arising just from the structure of material, isn't it? I mean, a crystal has a very precise salt crystal has a particular type of design. So it could be inherent in the structure of the components of life that designs follow from it. So there need not be a designer to design a human being. It may be a natural consequence of the basic units that are being thrown around. That there are maybe some thermodynamic arguments to say that the most favorable thermodynamic kind of assembly is the sorts of assemblies that we have here on the Earth. So then in that case, life elsewhere would be pretty similar to life on the Earth. And as far as intelligence is concerned, I think that it would be really very far-fetched to claim that we are anywhere near the pinnacle of intelligent life. There's bound to be, if these basic units are getting together in different places and forming creatures like ourselves or even more advanced than ourselves, then I think intelligence could be, we could be on the bottom of the intelligence ladder.
But we may not be able to confirm that given the distances and the difficulty of information traveling across the universe. It's difficult for intelligent civilizations to communicate in any meaningful way, don't you think?
Yeah, I mean, we've been trying, I think, astronomers and radio astronomers, and SETI is a case in point. We've been looking for possible radio signals that might have been sent out from other intelligent civilizations. And so far, of course, the results have been disappointing. So there may be ways in which evidence for intelligence is detectable, And we have, in a recent paper, Robert Temple and I have proposed that the genetic, if you look at the genome of a bacterium, right, there is a lot of redundant information there. And if it is possible for an intelligent civilization to put into a bacterium a whole lot of information in a coded form, right? A stretch of DNA that essentially is nothing to do with the function of the organism, but it's just a conveyor of information. So in that way, I think it may be possible theoretically, rather maybe fantastically even, to transfer information from one intelligent species to another, say a coded message in our genome, in the genome of a bacterium that comes into the atmosphere, say that we are here, we have come from this star system.
Right.
I mean, that is virtually, that's bordering on science fiction, but it...
No, but it sounds fascinating. Maybe you are onto something. To conclude, Professor, after over 6 decades in this field, maybe even longer, where do you think physics is in terms of answering fundamental questions that you and your fraternity grapple with?
I think we made a lot of progress in the details, but on the really fundamental issues of origins and so on, I think the discord is very strong. People don't agree with the various points of view that are in conflict. So I don't think we made much progress in discovering, understanding origins, even the origin of the universe. It is moving towards, as we said earlier, towards an infinite universe. But that position would be vehemently challenged by lots of cosmologists who are in power at the moment. So I think it's a handful of dissidents like Nalika in India, a dying breed, I should say, and the guy in Oxford, for instance, who holds to these views. And I think these views are going to be probably going to surface in the new generation of scientists. The old ideas have to die, have to be rejected, and new ideas consistent with the data have to replace these old ideas. And that's the paradigm. It's called a paradigm shift, isn't it? We are in dire need of a paradigm shift in terms of cosmology as well as in biology.
Or on the other hand, since we're talking about design as part of the universe, maybe it's designed in a way that we may not find the final answer ever. It's always a couple of steps ahead of us.
Yeah, that may well be. We can't.
On that note, Dr. Wickramsinghe, I want to really thank you for your time. I always find it fascinating to engage with you. I hope it was worth your while.
Thank you. Thank you.